So in this YouTube, we'll be covering content from your handout that was distributed on February 20th on item number 4, which is correlations, and item number 5, which is scatter plots. So we'll be talking through those analyses in this YouTube. So I'd like to start with this idea of what inferential statistics are. And with inferential statistics, you want to examine something in terms of how the variables interact with other variables. So for example, are these two variables related or are they associated? And we also, when we do inferential statistics, we typically get this estimate of are these results significant? So we talk about this idea of a p-value, sometimes called an alpha value. And so not only do we want to get this estimate of how related they are or how associated they are, but we also want to know if that relationship is significant. And today, and for this YouTube, we're talking about correlation. So a little bit about correlations. This kind of summarizes what I just said. One of the ways that we can examine how two variables are related to each other, especially two continuous variables, is to examine a scatter plot. And a scatter plot simply puts one of these variables on the x-axis and the other variable on the y-axis, and you get this picture of how of these data points that show you how related these two variables are. So this would be a perfect relationship, and this would be a depiction of no relationship. We don't see any pattern. Typically, we see the data points look a lot more scattered, but we see a line that shows, oh, this is a positive correlation, or if we see it going the opposite direction, this is a negative correlation. And often when you look at these dots scattered on this graph, you're looking at this rather faint upward trend or this rather faint downward trend. Many variables are related somewhat, but not strongly. So if it's positive, that they're going the same way. A higher body temperature is related to a higher heart rate. That would be a positive correlation. If a higher body temperature was related to a lower heart rate, you'd have a negative value. It's important to keep in mind that correlation doesn't mean causation. It doesn't mean that one of these is causing the other. So that's an important precautionary note. So let's take a look at looking at a scatter plot and then estimating the correlation between these two continuous variables that we have in this data set. So we simply go to Analyze, Correlate. We choose bivariate because we have two variables. Bi means two. And we want to look at that relationship between body temperature and heart rate. Now, if you have a hypothesis about how these two variables are going to relate to each other, you can click a one-tailed test. You have a little more statistical power that way because you're not looking at whether it's either or. You're saying, I think that a higher body temperature is going to relate to a higher heart rate. Because these are continuous variables, we'll select Pearson. We know these variables are normal from an earlier investigation. And we want to flag these significant correlations. We'll show you what that looks like. Let's see what our options are. We could request means and standard deviations. Kind of a good idea if we and when we exclude cases pairwise, it means that if you're missing a data point for one variable, it'll exclude that when you're looking at the relationship between that missing variable and the other. It'll exclude that case. All right, so let's see what we get here. So here we see this relationship between body temperature and heart rate. It's flagged it, and it's told us that this is a significant correlation at a p-value of 0.01. And it's not a real strong correlation. If you go back and look at that PowerPoint slide, this would be a kind of a weak correlation, a smaller correlation. But nonetheless, we have a positive correlation, so our hypothesis was supported. So now let's take a look at a scatter plot. Typically you look at your scatter plot first, but this time we're doing it the other way around. So we go up to graphs and we go to chart builder. We know that our data are all entered correctly, so we can click OK. And we want to look at a scatter plot. So we pick that option. And for this class, almost in every case, unless otherwise noted, you'll be doing the simplest version. And I think I'll put body temperature on this x-axis and heart rate on the top axis. And we'll see what our scatter plot looks like. So here we see these dots. And as we mentioned earlier, that's pretty rare for these dots to line up very nicely. But we do see this trend of running this way. So this would be a positive correlation. And we can see that because they're kind of scattered about, we have a weaker correlation. And even though we're not proposing a causal relationship, we're just looking at the degree of relatedness, I think it's sometimes helpful to put as what you might think of as the independent variable, the causal variable. I have noticed that when I have a fever, my heart rate is higher. And so I would argue that if there's any causality going on here, it's that a higher body temperature would result in a higher heart rate, even though this analysis isn't intended to allow an inference of causality. So the next YouTube video will take a quick look at doing correlations among non-continuous variables.